Before we go into the binomial expansion for rational n and not just natural number n, we're just going to look at some notational things that we used in the last video just to clear up. So n factorial, that we write with this notation here, and n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2, so on all the way into 3, 2, 1. Okay, so that's pretty simple. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120, or 3 factorial is equal to 3 times 2 times 1 is equal to 6. Okay, and you can have a few practices calculating these if you like, but hopefully that demonstrates the point. And here we go. This is both of these notations mean the same thing, and that is n choose r. So it's basically the amount of ways we can choose r objects from a set of n objects. And there is a formula for this. nr is equal to n factorial over r factorial multiplied by n minus r factorial. And if you're interested in sort of combinations and problems like this, maybe counting problems, card counting problems, I encourage you to think about why this is the formula. It's a good exercise, and then if you do come up with some idea and put it in the comments, I can tell you if you're right or wrong and help refine that idea. But I think that's a good exercise to try figure that out for yourself. We'll now go on to the binomial expansion. Okay, we're going to extend our definition of the binomial expansion for rational powers, but for rational powers there's a certain range of validity values of x we can actually take this for, but we'll go through that in a minute. The formula is 1 plus x, and it's important to note it must be in this form. So the power n is equal to 1 plus nx plus n multiplied by n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2, you guessed it, over 3 factorial x cubed, and so on, and the pattern continues like that. Okay, so bear in mind this is only equal to when we have all the terms, the infinite sum, but if we just want to take maybe up to x cubed or x squared, then this is an approximation, and this is often when we use this sort of binomial expansion idea for the rational n, because we, as I say, we can approximate things, and then we can work with that approximation rather than working with this, the more complicated expression. Now note that this is only valid for modulus of x less than 1. You just need to remember that. But of course you can look into it. And then next I want to look at a trick for if we have something in the form a plus bx, where a and b are constants, and this is raised to some rational power n. Okay, so note n's fractional, or it could possibly be negative as well. And the way we have to get this in the form 1 plus some function of x. Okay, so you don't have to have x here, but you always have to have 1 plus. Alright, and the way we do that is we take out a to the n. So this is equal to a to the n 1 plus bx over a, and hopefully you can see why, because to the n still, because we want to take out a from this expression, but bear in mind this is all to the power of n, so we have to take a to the n out. And now we can see that we've now got this form here, but instead bx over a is now our new x. Alright, so this expansion will get this equal to, it's going to be equal to the binomial expansion here, but we substitute in, instead of everywhere we've got x, we replace with bx over a, and then we have to multiply the whole expansion by a to the n, but that's just some constant multiple, so that's fine. And note that this is only valid in the range bx over the modulus of bx over a is less than 1, because that's our new x. Okay, so that's all the specification I want you to know about this. I'd encourage you to look at some problems. The last thing we'll do is maybe just calculate some of the terms of an expansion. So let's have 1 plus x to the power of 1/2. Well, that's equal to 1 plus 1/2 x plus, and then we get 1/2 multiplied by minus 1/2 over 2 x squared plus 1/2 minus 1/2 minus 3 over 2 over 6 x cubed, and so on. And you would simplify these expressions, but I'm not going to for now. The questions you'll get asked will be like, expand 1 plus x to the minus a quarter for up to the x squared term, or up to the x cubed term. You're going to have to do 5 or 6 of these. So I'd encourage you to remember the formula. I'm not aware whether or not this is in the formula book, so if someone could let me know down in the comments, that'd be great. But if not, you know, it's not too bad to remember. It's just a pattern, and if you practice a few questions, I'm sure you'll get used to it fairly quickly. If you do have any questions on this, let me know down in the comments below. If you enjoyed the video, please help me out by liking and subscribing, and I hope to see you in the next one.